My name is Dave Huson. I'm a Senior Research Fellow at the CFPR. My main research interest is 3D printed ceramics, and I'd like to show you some of the work that we've done with this. All the items you can see here are being printed by the powder binder jet process, which is a method of inkjetting a binder onto a layer of powder that's been spread onto a build plate. The build plate is then lowered and another layer of powder is spread on top, and another slice of the model is then printed. The process repeats so that when you have printed all the slices of the model, it's encased in the powder that was not glued together by the binder and then can be removed, depowdered and fired. These are some of the items that we've made. For example, we have the Denby sugar bowl, which is a result of a project in 2010. We were approached by Denby building work that's needed to produce a sample to present to a customer. With this process, we can take a CAD file, slice it in software and print out the ceramic on the 3D printer. Other work we've done for ceramics companies include Wedgwood. We made this airline tea tray set. They were interested into whether we could get the sort of glaze finishes that they need for their wear and whether we could do fine details such as the handles. We've also made parts for an architect in Holland. This is a lampshade that we produced several items for a project he was working on. And you can see from the structure, it's only possible to print that, or to make that by 3D printing. If you try to use a conventional ceramic moulding method, you wouldn't be able to realise these cutouts here. Another item that we've made is for a company called Kohler, and I'm sure you can recognise what this is. They are an American sanitary ware manufacturer interested in using 3D printing again in their studio design process. They wanted to have a precise specified ceramic surface to do water flow tests around the rim. Hence we generated this heavy lattice structure to keep the internal surface accurate during the firing, because all ceramics shrink and can distort in the firing process. We successfully made 3 parts of these for them as part of a contract research project. Moving along to some other things we made. At Halloween Open Day a few years back, we made this family of ghosts that had tea lights inside and their eyes lit up and glowed in the dark. This item is known as the Bristol tea bowl. It was designed by Peter Ting, a well-known ceramics designer. He'd seen our video that we produced with Denby Pottery making the sugar bowl and was interested in having one of his parts, one of his models, produced by 3D printing. It's quite a complex double-walled vessel with support structures built into the inner surface. This was displayed as a 3D printing exhibition at the Museum of Art and Design in New York. These pieces here were made for a Chinese artist. They are based on the Japanese concept of repairing a broken part and making it better, and they're actually designed to be jewellery holders. The piece of jewellery would fit in there and then be displayed in between the broken pieces. This project was quite a challenge. We needed to get as good a surface as possible, and the current 3D printing process can give quite a rough surface due to restrictions in the particle size range that can be used. So we developed various post-processing techniques to give us this very smooth surface which could then accept a thin glaze coating to give it a tight, high quality appearance. We've recently purchased a new type of 3D printer that solves a lot of the issues that were generated by the older printers we had, that are now obsolete and use technology from the early 2000s. The new printer has a much wider range of particle sizes that can be worked with, and has a high quality modern print head, so the process is faster and more accurate and will give a more refined piece at the end of it. Having had success with the 3D printed tableware ceramics, we had a 3-year project to investigate the possibility of developing a 3D printable self-glazing ceramic. This was based on the technology used by the ancient Egyptians, where soluble salts from plant ash were mixed with a silica sand material to form a faience body. The soluble salts evaporated during the moulding process and deposited on the surface a fine crust of the soda ash. When the piece is fired, that reacts with the silica in the body and forms a glass on the surface. The glass itself can be coloured by using various ceramic oxides. In the main, the most popular one was cobalt, which gives this interesting turquoise type colour. Because the process is defined and controlled by the evaporation rate of the soluble salts that are mixed into the body, different effects are caused that are not exactly under control, and it's only when you open the kiln that you can see what you're going to get. These 3 pieces here were all made at the same time with the same materials and even dried in close proximity, but you can see the different effects that the process gives. Hopefully this short video has given you an insight to the sort of research that we've been doing in ceramics. With the new equipment that's been provided by the E3 project, we now have the resources to take this work far further and have lots of ideas as to how we can develop 3D printed ceramics, both for tableware type subjects like this and also using a resin loaded 3D printed ceramics. We can move into engineering materials too.